Hello again. This is Math 2245 coming to you from the College of DuPage. And the title of this lecture is Reflections on Low Stakes Assessments 1 and 2. As always, please be attentive listeners while watching this video. Here I'm reminding you of what LSA was. LSA 1 was, it dealt with heat transfer and so on and so forth. You were to write a system of 4 equations whose solution gives estimates for these temperatures in the heat transfer problem, and to solve the resulting system. I did say by hand exactly, and note the row operations used. Again, I'm giving you these kind of directions because those might be the kind of directions that I would ask on a high stakes assessment, to note the row operations that you used and being able to do a problem like this by hand. Okay, the first equation was given as an example, and so we saw that T1 was equal to this, all this divided by 4. And if you reorganize this, where you have the T's in a different order, in order of their subscript, it would be 4T1 minus T2 minus T4 is equal to 30. Now the other equations, when you use the theory of averaging that we talked about, you get these equations. This is T sub 4 here, and that's a T sub 3. But then you reorganize these also, so they're in order of, actually I'm reorganizing so I get the numbers over here, and these are not in the order that I necessarily want to have them. But if we rearrange these for a standard approach to solving, we have 4 equations and 4 unknowns that are shown here. And of course we have the T1s, T2s, T3s, and T4s in columns. And I did suggest that what you do is use row operations, and so you start doing this. You didn't have to do it exactly like this, but this is one way to approach it. And you didn't 100% have to do this row exchange, but it actually was convenient because that made it into a 1. So anyway, what you do is you begin working, and you can use these row operations to do pivoting, and you get 1, 0, 0, 0 as the first column. Then we're going to pivot here, and we're going to make this 0 and this 0. And so if you do that, that's what I mean by this. And you get, these are the first 2 columns. Okay, then what happens is we, in the solution we're talking about here, you go to the final row, or excuse me, final column, and you pivot there, and you see I still have to go back and pivot on this 3rd column, but I do. And when I do, the last step, you end up with the solution is going to be T1 is 20, T2 is 27.5, T3 is 30, and T4 is 22.5. Here's the second LSA, and we had a little bit of discussion after class on this, but what you're supposed to do is actually prove this for an n by n plus 1 matrix. And again, you can think about this as this is an n by n rather, coefficient matrix, and then you have an augmented right-hand side. The reduction to echelon form can take, and again it says can take, that means this is worst case, 2/3 n cubed plus 1/2 n squared minus 7/6 n flops. And if n is big, the n cubed dominates, and so that's a way you could estimate this as 2/3 n cubed. I also noticed in passing that the size of the coefficient matrix is n squared, and you get 2/3 n cubed, which is twice the integral of n squared. The integral of n squared would be 1/3 n cubed, and that may be interesting for some of you, and maybe you want to think about that a little bit. And then after you've done this forward phase of row reduction, then you're supposed to do the backward substitution, and you're reducing this to reduced row echelon form. and here you need at most n squared flops. And again, this is closely related to calculations associated with turning something into the a matrix A into the LU format. So here we go. Now, the operations involved at the kth step, and you can think about the kth step being down here, and we're changing this to reduced echelon form, and k in this case can be 1 all the way through n minus 1. So this is the kth step. Those are the values of k, and for each row then, and now we're saying we're in the kth step, so we're looking underneath that, and so we're looking at the rows, and the rows then are going to be k plus 1, k plus 2, all the way up to n is going to be a count of the rows. And so for each of those, what we do is we compute the row multiplier and divide the entry, KL in my jargon here, by whatever I had as my pivot entry. And then you update the column entries the rest of the way, and so it is k plus 1, k plus 2, all the way to n plus 1 of the lth row. And each time you do one multiplication and addition. Okay, so you see we do item 1 and 2 for all the rows k plus 1 through n. Now if you count how many things are here, k plus 1 up to n, that really is n minus k. So we're multiplying by n minus k. The first step is you had to do this division, so that is the 1. And then what we're going to be doing is there's 2 steps here that you have to do. So it's 2 times, and this is n minus k plus 1. That's how many of them there are. And so you multiply those things together, and you get that for the kth step, you get 2k squared minus, and you have to do a little bit of algebra here, but this is 4n plus 3 times k if you multiply all that stuff together. And then this is going to be n times 2n plus 3. Now, so this is a convenient format, I suppose, for this. But then we're going to say, oh yeah, but we have to do that for each row k, and or k steps, and so we go k equal 1 up to n minus 1. So you see we're summing from k equal 1 to n minus 1, 2k squared minus, and this is 4n plus 3 times k, plus, and this is going to be n times 2n plus 3. And we're, again, please realize we're summing on k. Now I do a little bit of algebra over here, so I'm just repeating all this summation here, over here to get started. But then I can do this term by term, so I factor the 2 out. Here I'm summing this k squared. Here I'm summing on k, so I can pull out the 4n plus 3, and that's the summation of k. And then here, there is no k, but I'm adding it together n minus 1 times, and so I'm summing n minus 1 times that. Okay, now we have some formulas. I'll refer to them later, but in your calculus class and other places you learn these formulas. And so when you sum 2 times this summation of the squares, it is going to be the number of terms, which is n minus 1 times n plus 1, which in this case is not n plus 1. It is n minus 1 times n minus 1 plus 1, that is n, and this is 2, times the whole of n minus 1 plus 1, and this is all over 6. So that's what I get when I simplify this. Now here I'm summing from 1 to n minus 1, so that is a known formula. This is n minus 1 times n over 2, and then I'm multiplying by the 4n plus 3. And over here, I'm just adding this thing to itself, n minus 1 times, so I'm taking n minus 1 times this. Okay, now here 2 over 6 is a third, and so that's where the 3 comes from. And if you multiply these guys together, you get, and it's minus, of course, so this is 2n cubed minus n squared over 2, minus 3n over 2. But notice that here, over here on this one, I get 2n cubed. So this 2n cubed cancels with that 2n cubed. And so I continue doing my arithmetic. I expand this and so on. Now, the only n cubed term that I have then is this 2/3 n cubed from the start. And then I do pick up a minus n squared here, but that cancels with the plus n squared over here. And then, I do have an n squared over 2 here, which shows up here. And then I have n over 3, 3n over 2 minus 3n. And if I do all of that algebra, and I've outlined a lot of it here, you get 2/3 n cubed plus 1/2 n squared minus 7 over 6n. Again, this is the worst case for the forward calculation. Now we were to talk about the backwards calculation too. So the operations involved at the case step of this transformation were simpler. We're doing it for k equal 1, k equal n minus 1 all the way down to 1. And we're normalizing the entries down the diagonal. And that's only going to be one division for each thing from k to n minus 1, because this entry kk becomes 1 and all the other entries in that row are 0. And then what you're going to do, because of the row reduction that we did earlier, and then we're going to update the entries in this column, and that's going to be k minus 1 multiplications and k minus 1 additions. Now, when you see you've got a multiplication and addition, so you've got 2. So this is 2 times k minus 1. So for the case step, you have 1. That was this step right here. And then you have 2 times k minus 1. You do all that algebra, and you get 2k minus 1. But then we have to do that for each k from k equal 1 to n of 2k minus 1. Now, if you do that over here, I'm doing the same kind of calculation. So I can do this term by term, pull the 2 out. I'm summing this. Now, this time I'm going from 1 to n. So this is n times n plus 1 all by 2. And here again, I'm adding 1 to itself n times. So that is just minus n. And the 2's will cancel. You get n squared plus n minus n is n squared, which is the answer that you were supposed to prove. And inherent in my solution was recalling these things, and this is part of tradecraft that engineers and mathematicians should have. So the summation of the squareds is this, and the summation of k is this. And I actually used an additional tradecraft that if you add 1 to itself n times, you get n. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. Look forward to seeing you guys in class. God bless you all.